Hi guys, welcome back to YouTube channel Chemistry Lab UGPG. Today we are going to talk about determination of integral enthalpy of copper sulfate salt in water at room temperature. So this is in accordance with NEP syllabus. So I have a simple message for you guys. Please think for innovation, be creative, learn everywhere, anytime and help to learn others. So there is a disclaimer for this experiment. In this experiment, approximate data are used to give a real flavor about the experiment. And if you carry out your own experiment, you will get your own original data. So the aim of the experiment is determination of integral enthalpy of copper sulfate salt in water at room temperature. So what is the apparatus required? Beaker, polyethylene bottle, thin walled, cork with 2 holes, thermometer, measuring cylinder and stirrer. So what are the chemicals required? Copper sulfate and distilled water. So what is the theory or basic principle behind this experiment? The integral enthalpy of solution is the total enthalpy change when 1 mole of solute is dissolved in specific amount of solvent, representing the overall heat absorbed or released during the entire dissolution process. Generally, for 1 mole of solute, 4n times of the solvent is recommended. And the heat of solution is due to ionization or maybe dissolution, or some hydrate formation may be occurring due to the exothermic or endothermic process. So here copper sulfate 5 water is dissolved in water, giving rise to copper sulfate aqueous solution. And this is a endothermic one. So delta H is plus 11.7 kilojoule per mole, and this is the data taken from the internet. So this is the experimental setup. So this is the polyethylene bottle, this is the thermometer, and this is the stirrer. And here we have the solution of a copper sulfate 5 water in distilled water. So what is the procedure we need to follow? So take 25 ml of water in a clean and dry polyethylene bottle. Feed the cork on the polyethylene bottle. Insert the thermometer and stirrer in the 2 holes of the cork. Then record its initial temperature as T1 degree Celsius. Then add 0.5 gram of powdered copper sulfate to the polyethylene bottle. Then stir the solution to dissolve the copper sulfate completely. Then record the temperature when the copper sulfate is completely dissolved as T2 degree Celsius. So there is a note for this experiment. Specific heat capacity of the commonly PET type polyethylene bottle can be approximated to 1 joule per gram degree Celsius, that is equal to 1000 joule per kg degree Celsius, that is equal to 0.25 calorie per gram per degree Celsius. If the bottle is thin walled, its mass can be neglected if the mass of the water inside is more than 100 gram. And if the heavy bottle of different material is used, then we need to know and use its water equivalent. So what are the observations we got? So mass of copper sulfate taken 0.5 gram, volume of water 25 ml taken, mass of solution will be 25.5 gram, and initial temperature of the water is T1, that is 24 degrees Celsius, and final temperature of the solution T2, that is 28 degrees Celsius. So change in temperature will be 28 minus 24, that is 4 degrees Celsius, and we know the specific heat capacity of water is S equal to 4.184 joule per gram degree Celsius. So what is the calculation? So the heat absorbed for dissolution for 0.5 gram of copper sulfate is calculated as follows. Q equal to ms delta T. So M equal to 25.5, S equal to 4.184, and delta T is 4 degrees Celsius. So it is found to be 426.768 joule. We know the molar mass of copper sulfate is 249 gram per mole. So moles of copper sulfate 5 water is dissolved, that is equal to mass of copper sulfate divided by molar mass of copper sulfate, that is 0.5 gram we have taken by 249, that is 0.002 mole. So thus Q amount of heat, that is 426.768 joule absorbed when 0.002 mole of copper sulfate is dissolved. So integral enthalpy of solution for 1 mole of copper sulfate 5 water is delta H equal to Q by 0.002, that is the mole. So that is found to be 213384 joule per mole, that is 213.384 kilojoule per mole for 25 ml of water. So in conclusion, the enthalpy of dissolution of a given copper sulphate salt is found to be 213.384 kilojoule per mole experimentally when we take only 25 ml of water. So please subscribe to our channel Chemistry Live UGPG. This is the channel for class 11th and 12th students for that is Foundation Chemistry AB. So this is a simple step towards e-learning, making life better. Thank you all for learning.